Unit 9, Solutions. There's types of mixtures. A solution is a homogeneous mixture. Homogeneous means it looks the same. Mixture means that there's more than one component. Soluble means that you're capable of being dissolved. So insoluble, you're not capable of being dissolved. There's two components in every solution, your solvent and your solute. The solvent is the larger amount. It's the thing doing the dissolving. The universal solvent is water. The solute is the small amount, and it's the substance being dissolved. There's many types of solutions. The one that most people are aware of is salt dissolving or solid dissolving in water, like NaCl dissolving in water. But it doesn't have to just be a solid in a liquid. You can have two gases as a solution. An example of that would be air. You can have a gas in a solid. An example of that would be bread. You can have two solids mixed together, and that is called an alloy. That would be your brass and steel. So there's more than just solid in a liquid. However, that's what we normally discuss. You can talk about solutions as being suspensions, colloids, or a pure solution. A suspension, you'll see the solid floating in the liquid. But remember, it doesn't have to be a solid in a liquid. So you would see the solute in the solvent, and the solute will actually settle out if you don't constantly agitate the solution. Agitate means to mix or stir. So this picture shows us Italian salad dressing as an example of a suspension. A colloid, you see small solids in the liquid and it looks cloudy. Another way of saying that is you see the solute in the solvent and it looks cloudy or foggy. So fog is actually a colloid. You have water molecules in the air, so the water is the solute, the air is the solvent. Now the Tyndall effect is used to show that it is a colloid. The Tyndall effect means you shine a light through and the light scatters. So when we see fog in the morning, the lights seem to have this halo around them, and that's the scattering of the light. You can also refer to solutions being electrolytes or non-electrolytes. So an electrolyte is something that conducts electricity, and the reason it conducts electricity is because it breaks up into ions. So ionic compounds are electrolytes because ionic compounds will break up into positive and negative ions. Acids are electrolytes because acids will break into H plus and whatever else it's with. Bases are electrolytes because it breaks up into hydroxide and whatever the hydroxide is with. Non-electrolytes don't conduct electricity because they don't break into ions. So covalent molecules are all nonmetals and they don't break into ions, so they're non-electrolytes. Alcohols are also non-electrolytes because they don't break apart. You'll know you'll have an alcohol because the word alcohol will be in the name, or the name will end in OL, like methanol. Now the solution process is how the salt actually dissolves in the water, and we can watch a video of that process actually taking place.
Between the positively charged sodium and negatively charged chloride ions. When a crystal of sodium chloride is placed into water, the hydrogen ends of polar water molecules attract the negatively charged chloride ions and gradually surround them. Likewise, the oxygen ends of water molecules are attracted to and surround the positively charged sodium ions. The hydrated ions drift away into the solution, allowing new water molecules to surround newly exposed ions. Gradually, the entire crystal dissociates into solution.
Now we can cause the solution to happen at a faster rate if we crush the solute, and that gives the solute more surface area so more waters can break apart the solute. You can stir the solution, which makes fresh water molecules hit the solute more often. You can also heat the solution, and heating gives all of the molecules more kinetic energy, so they're just moving faster and the process happens faster. Solubility, you can also discuss it in terms of being saturated, unsaturated, or supersaturated. Saturated, you've dissolved the maximum amount of solute. Unsaturated, you've dissolved less than the maximum amount. Supersaturated, you've dissolved more than the maximum amount. How do we know if a solute will dissolve in a given solvent? We use the rule like dissolves like. So polar dissolves polar. Polar also dissolves ionic because they both have a positive and negative pieces. Nonpolar dissolves nonpolar, and alcohols actually dissolve both. So how do you know if something is polar or nonpolar? Polar molecules have dots on the center, which means you have to draw the Lewis structure or the Lewis diagram. And remember, you do want minus have divided by 2 to figure out the number of bonds, and then you can fill in with your extra lone pairs. So nonpolar then has no dots on the center. So water has 2 bonds. Hydrogens don't need dots because they only want 2 electrons, so they always share those 2. Oxygen wants 8, it's sharing 4, so it has 2 lone pairs. So because it has those 2 lone pairs, water is polar. And because water is polar, it can dissolve other polar things and ionic. So that's why it's the universal solvent. Because it's most readily available and it can dissolve both polar and ionic substances. So gas solubility, when we try to dissolve gases in liquids, we have to take 2 things into account, and that is pressure and temperature. So pressure, if you increase the pressure in this blue picture, you can see increasing the pressure, you're forcing those gas molecules into the liquid. Now temperature, if you change temperature, you're changing how fast the molecules are moving. So if you're at a cold temperature, the molecules are moving slower, so you can move more gas into the liquid. However, at high temperatures, the gases have more kinetic energy, so they're going to escape the liquid more often. Now, effervescence is the name that we give the sudden release of gas. So when you open up your soda for the first time, you hear that ch sound. That's the effervescence. That's the gas escaping the liquid very suddenly.